I can hear myself really well.
Oh, that's interesting because it's not up here. That means the speakers are pointed to the audience and we're screwed. Wow. I don't understand monitors. You know, the ones that face this. Okay, well. Okay. According to the clock on my laptop, it's time to begin. So let's get going. The next person comes through the doors. Would you close them, please? Thank you. Welcome to the second session of Lamps, or the composite session, as it were. So, next slide, please. As before, this session is covered by the note well. Please make sure you're aware of your rights and your privileges and your responsibilities regarding the processes of the IETF, your requirements to disclose IPR that you know about, and the code of conduct. Next slide, please.
Don't take your question. To make session 2 info, I think.
Okay. The please treat each other with respect. We had a pretty significant disagreement on yesterday, but all of the conversations stayed professional. I greatly appreciate that, and please do so today. Next slide. We got through a good bit of the agenda, but there was an agenda bash that moved all of the composite related things to today. On the last agenda slide, yes, 7 agenda slides. Keep going to the last one. We had under consideration for adoption, we got through A, but we did not get through B, and we had an agenda bash to talk about PKCS 11. So we will do the composite stuff, then we'll come to 7B, then the agenda bash on PKCS 11, unless there's an additional agenda bash at this point. Okay, that's the plan. Mike, are you awake yet?
I would take offense, but that's entirely justified.
Correct. Michael, it's one slide deck.
So, yes, I'm back. I'm not in the hospital this time, so all is well. Just for those of you that wanted to know. So yeah, I'm here with Mike, who will be presenting the composite signature and chem updates, which I'm sure you've all been waiting for. Oh, sorry. Is that better? Okay. We will be presenting the composite chems and signatures updates. And as I said before, I'm doing fine now. I'm not in the hospital. Everything is good. I'm here in person. So, and Mike is remote. So, thank you. So I guess you can go to the next slide. So yeah, if you've been looking at the drafts and the mailing list, you've seen there was lots of discussion. We'll get to the discussion about the key formats a bit later, but we just wanted to first go through the kind of the major changes. And Mike and I will kind of, go back and forth as well. So I guess I'll start on the slide. As you know, the component comps, the keys for both MLDSA and the chem, the secret keys now use only seeds. Obviously, we're going to talk about this a little bit later on the encoding slide. For the chem, we did need to add a new length tag to the secret key, and we'll talk about that a little bit more later. So that's, yeah, we'll get to that. a positive thing, we now have reference implementation thanks to Mike in the long plane flights from Thailand, which I know all about. He was able to implement composite signature and chem during that plane flight. And so we actually have test vectors in our both of those drafts. So thanks to you, Mike, for doing that. That's great. Yeah.
So I can,
Yeah. Just jump
if I can
in
talk
when you
about
want
that.
to.
Yeah, the reference implementation, I'm actually pretty happy with it. Not only is it a test vector, it also now generates all of the tables in the document. So all the tables that list sizes, tables that list domain separators, those are actually now spit out by the reference implementation, which I think is a pretty neat bit of automation. And not on these slides, but at the hackathon this weekend, I managed to integrate the composite signatures reference implementation is now an automated verifier as part of the hackathon. So anyone submits artifacts to the hackathon repo, they automatically get run through the reference implementation for SIGs. And I have a volunteer who's currently this week working on doing the same for chems. So we'll have the first automated hackathon chem verifier coming up this week too.
Yeah, it's pretty neat too, because about half the draft or more than half is basically automated now, all the tables and everything. So anyway, next slide, please. Yeah, so this one takes the place of those two CMS drafts. This was one slide. So we removed the use in CMS section. We did have a bunch of comments about it. We wanted to get the main core of the drafts through working group last call first before going back to finish this. We thought we could do them together, but we basically ran out of author bandwidth. And yeah, so our plan is, of course, once we get through the working group last call to the core, then we would go back and update the CMS draft. So all that content's been pulled out. We haven't actually published, I guess, version 0.0 drafts of those CMS ones. One question I had is because we got adopted with the CMS in the core document. Does that mean the CMS ones are sort of adopted? We'll just go straight to adoption. Okay, great. So that covers that. So that should cover two drafts. Go ahead, Mike.
And then I have a technical question here, and I've been chatting with Carl Wallace quite a bit offline, but the reference implementation I wrote is in Python. I'm not aware of a full-featured CMS library for Python, so I'm not totally sure what the path of least resistance will be to turn my reference implementation into a CMS implementation. Maybe I just restarting in Rust from scratch. I don't know. Anyway, if anyone has suggestions for an easy way to take a Python thing and link it up to CMS, please hit me up.
Oh, Richard Barnes, yeah.
So we have a Rust reference implementation of the CFRG hybrid chem thing. So if these two turn out to be the same thing and aligned, I think there's pretty good Rust CMS support. So that could also offer you an alternative path.
Yeah, rewrite my implementation or I guess start from yours. I'd have to implement signatures in Rust. Richard mentioned a really good thing, which is in passing, and this will come up more at CFRG on Thursday, which is this draft a proper subset of the CFRG hybrid chems draft? And it might be. And Richard and I have taken on an action to sync up the two of us next week. And if we try our reference implementations, if we try a reference implementation of the LAMPS draft against a reference implementation of the CFRG draft and they work together, that will be really cool. And I have a sneaky suspicion they will. And that will tell us something about what we should do for code points. Anyway,
great.
Next.
And we have the hackathon where we can do tests as well. So yeah, this one, we had a couple additional combinations that were requested. We always seem to get more combinations that are requested, not usually removing them, but you'll see in a later slide, we did end up removing a whole bunch of stuff. So anyway, yeah, so these are two combinations, MLDSA 87, RSA 3072, and MLChem 1024, RSA 3072. There's more performant alternative to MLDSA 87, 4096, PSS SHA 512. So essentially, you can just read the slides. But the other one was the P521 combinations. We did get a request to add those. And, there are people and places that use them and want them. So that's why we added them. That's that slide. I don't know if Mike, you have any comments?
Nope.
Or we can go to the next one.
We added some stuff. Next.
Yeah, so this one is a little bit, well, this is a major change. So if you remember the previous release, we had the pure mode and we had the pre-hash and we had basically duplicate sets of OIDs, well, double the sets of OIDs, because we were trying to align with what NIST did with the MLDSA and signatures. But we decided, and a lot of people in talking, lots of discussions, right? We realized we don't actually need the pure mode, just a single pre-hash mode, because you get the construction and it gives a lot of benefits, right? So first one is we were able to reduce the number of composite combinations. So instead of 30, we have 17 now. So do I get a clap for that? Because this is the first time we've ever been able to like really reduce. So we were able to reduce down to 17. So that was great. And it's still a lot, but it's still a lot less than it was. Then this also removes the need to use the MLDSA external menu trick like you could, right? You might still save a few extra, I don't know, 40 bytes or whatever, but really you don't need to do that now. And the pre-hashing is just done like, RSA, EC, like regular kind of things that you fit in today. We just do it that same way now. So that works really well. And we did add this randomizer thing. We had draft 05. We had the randomizer inside the pre-hash. We actually took that out. We did do a lot of security analysis and things, and we thought it made it stronger. But then after talking with people, and then we did put it on the list, there was some pushback on that. We did kind of expect that, so we just took that right out. So version 7 does not have the randomizer in the pre-hash, but it is still outside in the message format. And you might also notice didn't have it on the slide, but we did used to have it the hashoid like they do in the 204, the NIST 204 draft. So we don't have that anymore because our OID fully represents what the composite combination, what is done, right? So we didn't need that hashoid anymore. So you could kind of think we just replaced the consistent hashoid with the randomizer. And then the R has to go into the signature. Go ahead, Mike.
This point I would like to hear debate on. I'd like to hear either support or ambivalence or harm, because we've now got this R, which is making the signature value more complicated. It means that the signatures are, intentionally non-deterministic, cannot be made deterministic easily. Is this adding any value? Open question to the working group. So maybe we won't discuss that here, but would love to hear feedback. I mean, we can just take this entirely out.
Coming up. Here comes Sophie, I think. The next one on the list. Thanks.
Sure.
Victor's first. Okay.
Sure. MLDSA signatures are already non-deterministic, right? They need randomness for decent security.
There's hedged mode though, right? You can make them deterministic if you need them to be.
Yeah, I don't know that it's a good idea, right? So they're generally non-deterministic, right? So I don't know that we're changing things much with, most of the post-quantum things we're going to look at are going to have randomness in them. They're not deterministic by default, right?
Okay, thank you.
Great.
Sophie?
Sophie Schmick, Google. Well, MLDSA can be deterministic, and that's completely fine. That is a secure construction, and I will go to bat for that being a secure construction. I don't have a problem with this. I also don't see a benefit of this, but I don't have a problem with this. The biggest problem that I have is that we are now like almost a year from the launch of the NIST standards, and we are still doing a bunch of breaking changes here. When will this be in a way that I can actually?
We're hoping this is it. We're hoping if we get agreement, like if this working group, this will be it. This will be locked down, and we're.
But my main concern is like we need to get to something soon.
Agreed.
Because if we keep changing stuff, we don't need to bother with composite anymore. We can just do pure because quantum computers will be done already.
John, I like the change to shake 256 very much. If I use this, I would like to use that. This randomizer, if I understood it correctly, this removes the problem that some combinations, like if you use hedged MLDSA and hedged EDDSA, you would lose CMA property of both. But with this randomizer, I guess you can you will still have that even if you use like hedged MLDSA and hedged EDDSA.
So
if that was true, I think it's good.
That might be true, John, but that was not actually the reason we added it. We added
Yeah.
it because someone pointed out. So we had done a lot of work, especially with Britta Hale, on like non-separability, and so that was looking at whether you can take a composite and decompose it into individuals and trick a verifier, or can you take individuals and compose them into a composite and trick a verifier. So we had that already pretty robustly worked out. And then someone pointed out, it might have been Falco, might have been Dan Van Geest, I forget, that you can do a similar thing where if you have two composites, so you have 4 different keys
Yeah, mixed key
bundled up into
forgery.
2 composites, and then you start swapping around the keys within the 2 composites, you can create a signature forgery there. And so the randomizer is a protection against that attack. Whether that attack is valuable, I have no idea.
I see this as a news. I don't know if I split up my S key, I lose all the properties. Also, I don't care so much. But I think it's wrong if this removes CMA from the existing. If this lowers the security properties. So if this fixes that, I'm happy. But
Yeah, it
Okay,
was.
I see John and Deirdre and Sophie all have come. Maybe we take this to the list and we can tighten up the security considerations. And if we can't tighten them up, then we'll take this out.
Okay.
Was this one, Cloudflare? For better or for worse, people look at what LAMS does. And if we put in a randomizer here, people will think, oh, this is actually a really important thing we should do elsewhere. And I don't think it's an important thing, and I don't want people to copy something that's not useful. So that's my primary concern.
Sorry, did you say you don't think it's useful? I didn't quite hear you.
Yeah, I don't think the randomizer adds any real value.
Eat the mic, boss.
Yeah, I don't think we heard
Oh,
you.
sorry. Sorry.
Closer to the microphone.
Let me start from the start again. For better or for worse, people look at LAMS, what we are doing, and copy it, right? So my primary concern is that if we do this, then people will copy it and it doesn't add value, right? So it's not just about whether it's a problem for us. We do something useful, but people will copy us doing something useless, right? So that's my primary concern.
Okay.
Greeting from Huawei Singapore. So I'm a little bit curious about the use of random number in this way. So I mean, do you get any evidence how this way is good, either from standardization specification or maybe from some research paper, etc.? Because in some things it looks okay, the attackers have some kind of good freedom to choose different random number R, such that a forged signature could be produced. I don't know, but just not so.
So that
is a good question. I would like to take that to text chat if that's okay, either on the list or I see Richard Barnes just dug up the security consideration that I wrote and put it. Maybe just to keep our schedule going, we can take that to either the mail list or the Zulip room.
Yeah, like we did find, like Mike mentioned earlier, the mixed key forgery attack that we called it, where you mix up keys. That the randomizer does stop that. If people don't think that's an important thing to stop, we don't have to have it. But
okay.
So it's definitely in the security consideration section. So if you can read that. Now, if the concern is people are going to take this and say, well, they had an R in there and just think they should add an R for some other reason that isn't in why we put it in there, then that's probably a problem with future drafts, right? So we have our specific reason, and if people don't think that reason is good, I mean, we can remove it.
Okay, and again, just to remind everyone, this was a sort of security compromise in removing half the combinations. We had the pure mode and the pre-hash mode, and we merged them into one, and this was an attempt at a security compromise. But if it's not valuable, then great, cool.
Like we're just basically, we're not set on it, right? Like if the working group doesn't want it, we can remove it.
Oh, Richard. We'll get to that. We have a slide on that, Richard.
So are we good to go to the next slide, or is there more comments?
Yeah, next, please.
Yeah. But thank you for your feedback. Yeah, so this one,
Here you go. Here's Richard's comment slide. Okay, so Dan asked us in a GitHub comment, could we bind the composite public key, the whole thing, into the signature combiner? So where we have R here, correct, Deirdre, we're not signing over the randomizer, nor is it part of the pre-hash. And the reason for not signing over the randomizer is that some people want to produce one pre-hash and then sign it with multiple keys. That was a requirement we were given. So back to the slide. So Dan asked us to put, if we could put the composite public key into the signature combiner where we have R now, and that would allow weakening the prohibition on reusing key material. So could I have two different composite keys that have the same MLDSA component key? Right now that is forbidden and bad things happen to your non-severability properties. But if we bound the public key, then you could weaken that requirement. The authors spent many hours on this. We did a lot of analysis. We batted this back and forth. In the end, we decided to make no change. And the reason we decided to make no change is because it's basically the same reason that the external mu mode causes problems for people, which is you may not have access to your public key at the time that you're producing this message digest. And so in the end, we decided to make no change on this point.
That's the current, yes. Oh, Victor is in queue, okay.
Sure. Would it suffice to bind the OID instead, since it's not really the content of the key that's in question, right? It's which algorithms are in play, or am I misunderstanding?
That is already bound.
That's the domain. It's already there.
That is the thing we call domain separator. Yeah, if you want to go back to the construction slide.
Sure. So in that case, we don't need any of this other stuff, right? Or do we?
Can you go back? Whoever controls slides, can you please go back one slide?
Oh, can you go back one, Russ, just to show?
So
Sorry.
domain is the OID of the particular composite construction, particular composite algorithm you're using. So domain is already bound. I don't know, Dan, are you going to say what I'm about to say?
Well, yeah, basically, the binding domain wouldn't help because the concern is actually mixing and matching different keys of the same type into different combinations, similar to what you talked about on the last slide. And the reason I brought this up is because two meetings ago in like V2, I think, someone suggested doing exactly that. Basically, if there is a way for, and what that says, if we do something, someone's going to try and use it or abuse it. And this was someone trying to abuse it almost immediately. We have a way of combining multiple public keys into one signature. They said, hey, we can do that with independent keys that are not part of a composite key. And they wanted to use the same construction. So that's why I wanted to see if we could protect against other people misusing what we're doing here.
So I will point out to Dan's point, and don't go away. And I think I mentioned this in the security consideration. I think I did touch up the security considerations after we decided to make no change. You can, if you wish, so we expose a CTX parameter. You can, if you wish, stuff the public key into the CTX.
You could also put it into the private key, like we do with Chem, which...
No, that's a change to the document, John. But you can use the
I know
document
that's
as it is right
document,
now.
but I've talked...
Yeah.
Anyway, this we can also maybe take
that's
off.
That's kind of pushing it up to the protocol level to then...
It is, the application level, in fact.
Yeah. And also, like, I think the randomizer does fix this issue, whether we want to actually fix it or not. So
it fixes enough of this issue, yeah. Because if I have four separate keys cobbled into a composites in this way, and then they produce signatures, and then I try and mix them, the randomizer does block that. Yes.
But also, if you wanted to use one of those keys as a standalone key, I think it would also fix it because.
Well, that's what the prefix and the domain and blah 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 is in there for the sort of pedestrian non-severability thing. All right.
So I guess we're back at the next.
With this talk, I just want to expose what we're doing and take it to text chat for the details. I think.
So yeah, we made no change to the summary, and maybe there'll be some more discussion on that. Hopefully, it's okay the way it is now. So maybe go to the next slide. Yeah.
Okay, chems. So chems, we made a bunch of changes. Very few of them were interrupt breaking changes. So we basically reworded. There's a huge diff on the HKDF combiner, but actually almost all of it is just changes to the explanatory text. Very little of this is breaking change. We had a long back and forth on GitHub. So we had defined the HKDF combiner, and Richard Barnes, I'm talking to you because you do the same thing, or had the same thing in the CFRG document. The HKDF SHA-2. The observation here, observation number 1, MLChem outputs a 256-bit shared secret at all security levels. So if we're trying to mirror MLChem, we also output a 256-bit shared secret at all security levels. So even when you're doing HMAC SHA-512, you still want to output 256 bits, which means that the HKDF expand step will never get triggered, or at least it'll get triggered on loop 0, but never on loop 1. So we had text already in here that had said, when we say HKDF SHA-2, what we mean is HKDF extract without the HKDF expand step, save you one hash iteration. We got comments that this is extremely confusing. And so I went through the document and systematically renamed this to HMAC combiner. And I just ripped out the reference to the HKDF RFC entirely. So now we're just directly inlining the HMAC construction. So I just lifted the HMAC construction out of HKDF and said, do this. And we're now no longer calling this HKDF anywhere.
Yeah.
Scott.
Same thing, yeah. And then I think you mentioned about the
is Scott and Quinn. Sorry,
truncated.
Scott and Quinn coming to the mic about HKDF.
Oh,
Yeah, I think me and Quinn are going to say the same thing about the second. Hello? Okay, come on. Hello?
Okay, well then let me do the second point before you comment on the second point. Okay, so the second point, Richard Kettlewell, very sharp eyes, noted that SHA-384 is just truncated SHA-512. So when we say SHA-384 truncated 256 bits, that ought to be identical to, Scott's about to tell me I'm wrong, but that ought to be identical to SHA-512 truncated to 256. When you put it in an HMAC, that's no longer true. So HMAC SHA-384 output truncated is not the same as HMAC SHA-512 output truncated. So I made a bit of a slip. This is not quite exactly directly interoperable, but security-wise, might as well. So we've gone through, a change we made here was we removed SHA-384 from the document. So that's just one less primitive, one less thing to have to externally reference, one less OID. So now we're only using SHA-256 or SHA-512.
Yeah.
Scott.
As you pointed out, SHA-384 is not precisely the same as SHA-512 truncated. It has different IVs, and so they don't. And so, security-wise, they're almost certainly the same, but they are slightly different. So
yeah. So the test vectors did change, and I misspoke earlier.
Okay. Thank you.
Yeah.
Quinn is going to say something. Okay, perfect. So yeah, so this was a lot of lines were changed as a result of this, but it's all really, as far as I'm concerned, editorial.
Yeah, and we did it in the hopes of clarity too, right? Like it's I think much more clear now what it is than before. It was a little bit confusing, so hopefully the working group likes that. Okay, upcoming.
Here's a change that we have not made yet. This we started working on after the submission deadline. So Weijun Wang from OpenJDK made a very good observation on GitHub that you need the traditional public key in order to perform a decaps. And for things like X-Wing, that's okay because you're trucking around the seed, you can regenerate both halves of your keys, no problem. But here we're not requiring that the seed of the traditional half get trucked around. So it's not necessarily clear that you will have access to the public key at the time that you're doing a decaps. And the authors sort of went, whatever, get it from somewhere. And he was like, no, get it from where? Like be specific on this point.
Mm-hmm.
Yep, that's true. So we've gone ahead and explicitly added the traditional public key to the secret key format. So now the secret key is a 3-tuple. The MLDSA, MLChem seed, the traditional public key, and the traditional secret key. And now, unfortunately, we have 2 things in here which are non-constant length. So we needed to add a length tag to deal with that.
So I'm going to make you go back.
Oh,
so I'm going to make you go back. Can you go back to the previous slide? And I'm very, very sorry. So I just want to make sure you realize that you can't you're going to have to specify the whole SHA-512 truncated to 256 bits stuff, because that's not
is.
actually a thing, right? Because
Yeah.
SHA-384
Yeah, so-
is a different IV.
In fact, what we specify, and if you go read the section that gives pseudocode for our combiner,
Yeah.
what we specify is HMAC SHA-384. You do that, you get a shared secret, you then chop the shared secret down. And we've got pseudocode for that. So I think that is sufficiently well specified.
So I thought you said here you're taking out SHA-384.
Yes. So
Change
you
all
do
the
SHA
SHA-384s to SHA-512.
512 truncated
right.
to 256.
So you do HMAC SHA-512 fully. You arrive at a 512-bit shared secret,
And you truncate.
and then in the next line of code, you chop it down to 256
Okay,
bits.
you just have to
That's-
specify that, because that's not, as Scott says, not the same thing as SHA-384, because the IV values are different.
Sure. I think
was-
it's clear in the document. If you could go read the
That's
section, whatever, 3 point something that defines the combiner, and if it's not
That's fine.
sufficiently clear to you in the document, that would be, yeah, please.
I'm not reading it until it comes to me, so it's going to be a minute.
Okay. Okay. It's there anyway, so.
That's
yeah.
fine. That's fine.
I believe that's okay. I
You
believe
just have to,
we're.
you just have to realize that you have to now specify it, because it's not.
Oh yeah. We have got pseudocode and everything for
Yeah.
how to do the combiner, and I think it's.
As far as I know, there was no real good reason to make that IV different, other than just to make sure that you knew there were two different things. Anyway, but that's another
Yeah.
story. Sorry, I'm sorry.
Bus.
Ask Cloudflare. So if you go one slide forward again.
I go one slide forward.
Well, yeah. Okay. So the point of a private key standard is that it's portable, right? So it's about getting from one application to another, right? So the traditional public key can be computed out of the traditional secret key. No need to have it there unless you want to save some time. But for portable, if you just move the private key, then that's not important. Your application can cache the private key, the traditional public key somewhere. There's no need to have the traditional public key here now. Just remove it and recompute it when you need it.
Yes.
I think there's some subtlety in that argument. Let's have that on the list also.
Yeah, we had
apart.
that was when we put this. There were like 3 choices, and that was one of them. Yeah, I think talking about it on the list would be good, but it does add some complexity for implementation.
What Boss just said raises questions about whether all crypto libraries expose an API for rederiving an elliptic curve or Edwards curve or RSA public key from the private key. I think not all crypto libraries support that API. The questions, yeah, let's maybe defer that to writing, because I think we should explore that.
Yeah, this seems like a point on which some existence would be useful, because all of the ones I know of have that API.
Great. No, that's
Okay.
helpful.
That's good.
Let's
No.
let's do that. Like the last bullet on this slide, I really don't love now that our private key and public key formats are mismatched, 3 components, 2 components, and also the private keys of the composite signatures is now mismatched from the private keys of the composite chems. So like, yeah, I made this change with with much hesitation. If we can undo it, that would be excellent.
And that's why it's in a pull request and not actually part of the document yet.
Yeah, exactly. Yeah, so please, if the list thinks this is unnecessary and this will behave perfectly fine, and we're allowed to go back to being vague about where you get your public key from, that would make me happy. Next.
Yeah, hi, here's Stavros from BSI. Mike, can you go to the slide with the HKDF stuff?
Oh God!
I just wanted to make
This
you
was supposed
aware.
to be an easy slide.
Yeah, so just wanted to make you aware. Be careful which part of HKDF you're ripping here apart, because at that step, at the combiner step, you will need a PRF. I just wanted to say I can offer a review there. It's fine for you.
Please, yeah. So again, that's section 3 dot what I don't have it in front of me. 3 dot whatever the combiner, the little 3-line Python pseudocode that defines the combiner is the relevant
That's
section
all.
here. Please,
Thanks.
please review that.
Is there anyone else? Okay.
Okay, next and next again. Okay, and next again. Okay,
Okay.
encodings. And
Yes.
they've got this slide twice.
Oh,
Oops.
you have the old slides, I guess. I fixed that in the update, but anyway, it's
Oh, well.
okay.
Yeah, I gave a talk at PKIX yesterday. I did a whole 20 minutes of this. Yeah, let's do this. So the authors believe that what we have now is correct, which is a simple bytes-like, you take the MLDSA thing, you take the traditional thing in whatever encoding the traditional thing happens to be, and you concatenate them together, and that's it, you're done. No wrappers, no ASN1, no CBOR, no length tags, nothing. It's just super, super simple. The reference implementation deserializes a public key in one line of Python. You just do array slicing and that's it. The deserializer is an array slice, comma, an array slice. To me, this is beautiful. I love it. The fact that TLS and Jose have taken this encoding verbatim and not felt the need to rewrap it, to me tells me that other people think this is good too. And I'll make this point. Remember that composites aren't really part of PKIX. They just happen to be in LAMPS because CFRG wouldn't take them at the time. But as far as I'm concerned, composites are an algorithm, not actually a part of X509. And so to me, it feels extremely weird to put X509 baggage inside an algorithm, but that's maybe just me. And now we have a queue. Victor.
So what you've swept away is the fact that, in fact, MLDSA keys don't have a single length, and not everybody agrees about seed only. In fact, there's a set of communities that really
let's
don't.
talk about private keys. I have a separate slide on private keys.
Right.
So public keys
okay.
and signature values and ciphertexts first, and let's talk about
okay. So you want to separate those two topics?
Yeah, I do. I think we can talk about public. I think we can talk about public values separately from private values here. I think that's probably helpful to do.
Okay. So I don't have examples of variable length public components in the PQ space. I don't know whether any are coming. Adding a couple of lengths that are themselves fixed length doesn't seem to change the complexity of that Python code that does array slices. It just gets to skip 2 or 3 bytes, right? Why don't we just do it? And if we do the same thing with the private key, it just unasks the question and we move on, right?
So
throw
this
in
is
3 bytes of the length and nobody will care. Well,
okay,
I will
so this
care.
this is a question for the working group. We've been told, the authors have been given extremely clear instructions by LAMPS. Do not generify this. This is not a generic construction. You are specifically working with MLDSA and MLChem. Do everything in your power to make this optimized for MLDSA and MLChem. The working group has been extremely clear on this point. So if we then want to consider, let's future-proof this for things that we don't even know about yet that might be variable length. And by the way, nothing, as far as I know, in the NIST pipe is variable length. So like we don't even have an example to point at about what we're future-proofing for. But if we want to make this document more complex, even epsilon more complex, to accommodate future things that don't exist yet, I need the working group to give me that direction.
Hi, Sean Turner. I'm wearing my process nerd pedantic hat. TLS has not yet adopted that draft. It doesn't look like Jose has yet adopted that other draft too. So I just want to make that clear.
Good. Fair. Yes. At least some authors in those working groups think that this is the right approach. Fair.
Falco Strensky, MTG. So I'm not fully into the topic of the key encoding, I must admit, but I just want to point out that at the crypto layer, as you argued yesterday, to treat this as a monolithic thing, I don't think it will work, because at the point that you are involving hardware modules, you'll need to split the algorithms, because no hardware modules will exhibit the composite algorithms.
Some might, but many won't.
No, because PKIX 11 version 3.2 proposal is out and there are no composites in it. So
right, but I think they're considering adding composite mechanisms for 3.3. At least it's on the table for discussion. So yeah, none do currently, but some might in the future.
It's not in 3.2,
yes.
but hopefully the future. Yeah.
Okay,
but so the question then, Falco, is the thing you just described a protocol layer concern or a crypto library concern? That's the core philosophical debate here.
Well, my concern is that when you're in the application code and you're at the point where the software invokes the hardware module, that then you have to look up into a table the lengths of the components. So as long as these specific composites are not offered by the HSMs, then it will not. You will have to use these tables.
Right. So okay. So I grant you that that is valid. On the other side, if we start putting ASN1 in our public keys, then also Jose will put CBOR in their public keys, and Jose will put JSON in their public keys, and now we have 3 different public key encodings for the same public key. Is that more harm than the lookup table that you're describing? I argue yes, that is more harm than the lookup
Maybe
table
there
you're
are other ways. Maybe you can have a non-ASN1 length encoding or something.
Okay.
That was my
so I think
suggestion.
there are other people who want to voice their opinion. I said what I had to say.
Right.
Yeah, I don't see how that would change anything if I have an HSM. If I have an HSM that does not support the thing as a whole, I need to parse the thing. Whether I parse the thing with an ASN.1 parser or with C++ built-in string pointer arithmetic doesn't matter all that much, other than the ASN.1 parser happens to crash a lot, burn the world while it's doing that, and ends up forcing me to put it into sandboxes because I can't get rid of all the vulnerabilities it produces. Just use a fixed string encoding for crying out loud.
Thanks, Sophie.
Victor?
ASN.1 parsers don't crash. Implementers who are from the 80s, and haven't grown up crash. But anyway, regardless, if you're parsing a private key, you're already parsing ASN.1. If you're parsing a public key, you're parsing ASN.1. You already have that problem. But anyway, so I'm not buying that repeated ASN.1 crashes nonsense. But anyway, back to this. I'm not asking for ASN.1 anymore. A fixed length with no tag.
Okay.
That's
okay. So you're asking
we're
Victor,
converging
for like what we had in version 04.
24-bit length prefix. So makes it
we had
generic.
we had a 4-byte version length before. So
Fine, 4 bytes.
Well, 3 would work, but we did 4. I guess we talked about this at one of the IETFs, and I think
I'm hearing consensus.
suggested
I'd
4.
like to call consensus on this before anyone else comes to the mic.
Yeah.
Can the minute taker please note that we have consensus for a 3 or 4 byte length tag, and then we'll just do it.
Like, are people fine with a 3 or 4 byte length tag? We're happy to put that back in. We had it in version 4. You can see it worked. I even had a composite implementation with it there. So if the working group is willing to live with that, we're happy with that.
Phenomenal. Okay, well, let's.
I don't see anyone going to the mic to object.
Oh my God!
Boss is coming up.
Thanks, boss.
I object.
Why? Why do you object?
Yeah,
don't
why?
No, don't walk away.
So what value does it add? What value does it add?
At least for the private keys, it makes it possible to split them apart in the same way, regardless of which pair of algorithms are being combined. It support variable lengths for the private key stuff, where in fact they might be variable lengths.
So we have the next slide coming where we bring up the Great Private Key War, seed versus expanded versus both.
And for the public keys, if you're generically splitting them up for algorithms that the HSM implements, but you don't really know, much about the algorithms, you just hand them off. You also get to do it without having to write special code for each one of the algorithms. It's much simpler to decompose the key when there are 2 lengths. It also, if there's any problem, it's much easier to detect that there's a problem. The key adds a little bit of redundancy.
Redundancy.
The length adds a little bit of redundancy.
It's another failure mode, so that's a problem. It's other side, and also when you put it on that layer, you're putting it on the wrong layer, right? If you are parsing
the
public key,
microphone,
you need
please.
to support it in the first case. Sorry. So if you support So you're only parsing the public key if you support it. Otherwise, it's no point to it, right? And if you support it, you need to have it already in the layer. There's no point. You already know how to split it. I mean, you need to know, in the first place, you need to know where to dispatch each of the public keys. If you are going the abstraction route, you need to know where to dispatch each of them. Then you can also add in the table the length of the fixed public key component. So I've implemented these algorithms, hybrids, many times. I've never felt the need to do something like this. Is there any? Yeah.
Dennis Jackson,
Okay.
Mozilla. Like, this is a fixed length thing. I don't understand why we're considering adding an integer, which is always going to be a value that the client has, the library has to know in advance and would need to check anyway. Like, there's no way around this. It's fixed length. There's no need for this to be there.
Are we absolutely sure that nobody will ever put two classical keys together in a composite where the classical keys are variable?
Well, if they do, they can write a new
Certainly
draft.
not with the OIDs registered in this document.
Victor, that would be a different draft.
It's a fixed length, but will it change?
I mean, it's Yuri's point. If it changes, it's a different algorithm, and you have different logic for parsing it.
Exactly.
Yeah. Yeah, I think I was in queue to just say what was just said.
are.
So I'll drop.
So Vickers, yeah, just to echo all of the other people, I don't believe that you have special code. You just have, oh, we're parsing ML Chem 512, we're passing that to the ML Chem 512 module. You need to decide that routing anyway. Add this is that many bytes I need to take from this string in that layer, and don't put in extra bytes for length parsing. You're gonna have to do the lookup of the number of bytes in some other place anyway if you include the length of the public key in the public key. It makes no sense to me.
Okay, queue is empty. Thanks, Tom. Chairs, do you think this is a pollable question? Do the chairs think you could construct a well-worded poll
Okay,
question
hold on.
here?
Yeah, I mean, we need a decision on this.
Do we want to add a 3 or 4 byte length tag that encodes the length of the MLDSA component? And you know what? Actually, sorry. Hold that. Let's get to the private key slide first if we're going to do a poll.
Wait a minute. You wanted to separate those discussions. No.
Okay. All right, fine. But the answer is going to be inconclusive.
Just for the record, if this is public key only, I can cave on the public keys for lengths.
And then the second question there, Victor, is how hideous do you think it would be to have a length tagged private key, like to mismatch the private key and public key encodings?
Not a problem. The private keys are a whole separate matter from the public keys.
Okay, then I'm happy to treat these as decoupled. Great.
So I think the question you're asking me to ask is, do you want to include the length explicitly in the public key?
Public key, signature value, and ciphertext, like public values.
Okay.
I'd like to, but I can live with if it's not there.
Okay, he says he can live with it's not there. So, is there anyone that? I don't think we need a question.
We'll do the poll.
We'll do the poll. Okay.
That's a much better poll than my CSR test poll. So Russ is fond of asking, can anyone not live with it, instead of do you want?
Okay, it's pretty clear to me that it's overwhelming, 3-1 at least. Would any of the 8 be unable to live with it if the explicit length was not present.
Again, public values. We'll talk about private keys separately.
Okay, so I think the direction to the authors is no length as was already written in the document.
For the public. So
Great.
check
We'll
some
just go
signatures.
grab version 4 and republish that
Yeah.
because that seems to be what we're deciding here.
Well, no,
Everything we've
it's
done
version
this
7,
before.
Mike. It's
No.
version 7. It's the current one. We don't have to change anything.
No change.
Oh, I'm sorry.
Yes,
This
don't make
is
these
the current
changes.
one. Yeah.
Okay.
Great. Deirdre?
Hi. Including the domain separator already encodes the lengths because it is unique to the specific parameter set of MLDSA number and RSA number.
Yeah. Well, it implies the lengths. You saw if
No. Like you go look up, like these are 1-to-1. It's not parsed out of a thing that a adversary can hand to you, but you can go look up the domain separator and see an exact 1-to-1 what these lengths are supposed to be.
Yep.
So I think
you need a lookup table in your code. That's what
yes,
we're
you
talking
need a
about.
lookup table,
exactly
but
how we implement
we
it.
don't lose it if we don't include it explicitly in the format. We have it.
Yeah.
Absolutely. Okay. Can I go forward one more slide? I sort of regret the order in which I posted these. So yeah, okay. Private keys. We're probably the same poll for private keys. So yeah, so this is the great private key war. This is the right now drafts 07 mandate only seeds, and the authors discussed this in quite a bit of detail, and we were pretty clear that this was the consensus in the room at Bangkok. So we implemented the consensus in the room at Bangkok. If the consensus in the room in Madrid is different, okay. But this is where we landed at the end of Bangkok. So this is what's in 07 is seeds only. And that's really nice because they're small and because it's only 32 or 64 and it can never be anything else. But all of the arguments from the Great Private Key War are still valid, that there exist crypto modules that don't support seeds, and what do you do with those? And do we just forsake them to never be able to do an interoperable composite? That's the core discussion here.
I think Victor
And like this was brought up in Bangkok, and the sentiment in the room was, this is greenfield, too bad. That was our, we went back and rewatched the recording, and that was the sentiment in the room. So are we reversing course on this decision?
Yeah. So Bangkok, we had about 30 seconds to consider the issue. This really deserves more time on the list. I didn't want to make a fuss in Bangkok. It was clear that there wasn't really an opportunity to discuss it at length. So I don't consider the Bangkok consensus to be meaningful. It was just a brief poll, but not really a deeply considered issue. So it was decided on the basis largely of, since there are no greenfields already published keys, therefore done. But that's not really a sufficient analysis of the need for expanded keys in the composite space or dual or whatever. So we're pretty clear on, at least in some communities, that the single seed format will not suffice for composite. There will be use cases that need expanded keys, even in a composite situation. And so the keys are, in fact, then variable length, because there are 3 possible lengths, depending on the key format that's chosen for the representation. And so we have no choice but to encode a length and to support the non-seed formats. That's where I'm coming from.
We either encode a length or we encode a tag that tells you which type of key it is. I could see 2 possible design choices there.
It appears that be it composite, way closer. Say again. Way closer. Even closer. Yeah. I'll be kissing
better.
Case.
Yeah.
Anyways, be it pure, be it composite, it's fairly obvious that seed format overwhelmingly better performance-wise, convenience-wise, And since seed determines expanded uniquely, there is no real justifiable need for both. Therefore,
So-
what to do with modules that do not support seed?
That's the question.
Update them or dump them. I don't care either way.
That's not.
Yeah,
That's not.
my thought oh, sorry. Yeah, I was going to say with that one, what modules don't support it? Because I've been trying to, I keep hearing that argument, and everyone, HSM vendor I talk to say if they don't support it, they're going to. So which ones don't support it? I'd like to hear
Please
that.
raise your hand if you have ever seen one of these things.
Okay.
It's
Fair.
not which one doesn't support, it's which one doesn't support and will not support, no
exactly.
matter what. Show me
On the
that
timeline
vendor.
you need to deploy this thing is an important second half to Uri's sentence. Will not support on the timeline you need for deployment. Because I do know there's HSMs that are going through FIPS now, and their FIPS version will be available shortly, and then they'll have to re-FIPS to add the seed stuff. And that is, I think, valid distinction.
Yeah.
David Benjamin.
David.
So to echo all the things, you can update your modules. So you can update your modules. The difference with the previous one is that there were existing keys whose seeds were lost. And so even if you upgraded your modules, like understandably the folks with those legacy keys, I don't know how we already have legacy MLDSA keys, but okay.
The draft
Those
isn't
keys are
finished.
stuck. We forbid key reuse in this thing. There are 0 legacy MLDSA keys. So even if you have a legacy module, you have a path to upgrading a module in a way that you didn't have before. And so like this is not the same situation that we were in previously.
Victor.
Yeah, module upgrades are not so straightforward. People will have bought modules. They will be using those modules for some time. They're not always well positioned to upgrade them. What exactly is the problem here with having the same private key format that you already have for a standalone key to use it as a composite, not asking for much, just a length tag and the ability to encode the key in the same way that it would be encoded if it were standalone?
Dennis Jackson, Mozilla. I think, we've had a sense of this in Bangkok. We had a sense of this in Bangkok. We've had a sense of this in the room today. I think we should probably try and close this. I don't know that there's any need to keep discussing.
I would love the chairs to chair hammer this, and then the authors will do.
Yeah. Are you putting a poll together, Russ?
Yeah.
Russ is putting a poll.
And we have one more slide that probably needs a chair hammer, and then we're going to get off the stage.
So the question is, can you live with the seed-only private key format?
That looks pretty overwhelming.
Huh. Victor, you're in the rough. Moving on.
Wow, that's more overwhelming than I expected. Okay.
That's great. Thank you. That's what we've been looking for. We can move these things forward then.
All right. Moving on actually means going back one slide.
Sorry, you want to move which way, Mike?
Yeah,
Oh,
this
this way,
slide.
this
I
way.
skipped. I put the slides in a bad order. So this is the last debate point that I want working group feedback on, is the encoding of the traditional part. As I expanded on at PQIP yesterday, elliptic curve in particular is annoying in that it carries multiple different formats. The RFCs for EC point allow you to do byte 03, which is uncompressed, and byte 04, which is compressed. Also, there's the like X962 thing. RSA is generally only one thing, except the private key can be either D or Chinese remainder theorem. So like the question here is, what is the design requirement? So the composite authors took a design requirement, which is the traditional part is black box. If you have a FIPS certified module that does the traditional part, we're not allowed to mandate anything inside of that. So we took that requirement to mean if a particular encoding is allowed by an RFC, then that particular encoding has to be allowed within the traditional component, which is like a massive source of non-fixed lengthness and a massive source of potential compatibility issues, because I can support this composite algorithm, but then I run into a traditional key encoding that I don't support, and that's like a mess. But we took that to be handcuffed by the design requirements of this thing. So I want to have this debate, which is, are we allowed to pick a single encoding for the traditional stuff and just fix it? Or do the design requirements for composites not allow us to do that? Because anything allowed today has to be allowed in composites.
It appears, okay, people are getting in the queue now.
You're mixing the public key into the combiner function. You have to decide on one format. You can't have someone who has loaded a public key re-encode it.
That's true of chems.
Yes.
We don't
Yeah,
currently mix the public key.
Oh, sorry. This is just signatures we're talking about.
No, that's fine. I'm just
chems.
clarifying. Your comment applies to chems, not to signatures.
Yes.
It's still a valid comment.
Whatever we do for chems, we should also do for signatures. I don't want to have
Great.
two different things.
Okay, so yeah, as I mentioned at PQIP yesterday, if you allow multiple encodings in a thing that's binding the public key, you're asking for trouble. Okay. And so we're in a pros and cons situation where on one hand we're risking interop issues with encodings and public keys and blah blah blah, and on the other hand we're risking interop issues with perfectly valid FIPS modules that now cannot be used as part of a composite. Which one of these things is more important to the community? I see Rich.
Yeah, in terms of deployment issues, OpenSSL point to that. Okay, in terms of deployment issues, OpenSSL downplays compressed format. Boring, Libre, Quick TLS have all removed it. So if the software is more important than the FIPS hardware that can't be changed, go with the uncompressed only.
Can that be in the minutes, please? Rich votes for uncompressed only.
I see Scott coming up.
Scott,
Mhm.
am I close enough? Yeah. What new interoperability issues are we introducing? If there are existing ones for traditional, that's not this specific problem we're addressing. If we are, I don't see how we are mandated to fix existing problems with other crypto.
So what we'd be introducing is that it would be valid to write a composite that only accepts a certain format. It would be valid to write a composite that just fails if it like to Rich's example from a second ago. If we say that composite key must be uncompressed, and then you encounter a compressed one, you just fail. That's introducing an interop issue that didn't exist before, because before you were required to support both on your parser.
Yeah, just that if by the existing, if we are assuming that we have an existing traditional thing which we are not allowed to touch, basically we should allow anything that the traditional assumes. That's my opinion.
You vote for.
Yeah, and Scott is an author as well.
So Scott votes for allow anything that's allowed today. Victor.
My take is IETF should optimize for interoperability first. Yeah, that's what the IETF is about.
And
So
which
whenever
way
there
does
might
that
be
make you
problem-
vote? These are both interoperability arguments.
Well, interoperability with existing implementations, right, of these various algorithms, right? So, make it possible to use this in the largest possible set of contexts. So I think that means support both point formats. So everybody would be expected to support compressed and uncompressed. If the expectation is, on the other hand, that we're creating different non-interoperable camps and just tolerating that in the spec, that wouldn't be so great, right? We strive for interoperability. So, either everybody does both or we're forced to pick one, I guess. But the idea
So
should
we
be
could
that both.
we could do what Victor asks and what Dan asks, which is that you could put your public keys in whatever format you want, but when you feed it into the combiner, you must uncompress it before you feed it to the KDF. We could do some
Sounds
nonsense
okay.
like that.
Yep.
Tom Wiggers, am I understanding correctly that you can just convert from one format to the other? This mic is really annoying. Especially because I'm quite tall and it's set to very low. Can we not just convert from one format to the other? Why? And if that is the case, then we're not leaving any crypto modules behind, right? Because then you can just convert it to whatever the crypto module understands, and you have maybe a slightly more complex thing on top of the crypto module. But is that worth having all of this on the wire negotiation, figuring out what format is being transported, yada yada?
Yeah.
Yeah, it's
Good
not
comment.
like the seeds versus expanded where there's a PRF involved. These are, translatable encodings. Yep.
Yeah, hi, Saros again. So I would go for uncompressed. And so for byte
Please get
04,
closer to the
which is
mic.
uncompressed. So I
Get
know
closer
that.
to the mic.
Closer. I'm so small. I'm close enough. I would go for uncompressed byte 04. 02 and 03 are compressed. I know there's existing encodings, but I would say we are defining new algorithms anyway. So maybe we should take the liberty of making things simpler. That's my opinion.
And as pointed out by Tom, if you have a crypto module
And
that
anyway,
doesn't do that, you can always wrap it in software.
You're saving 10, 20, 30, 40 bytes. If you care about this, and I don't know, you didn't understand PQ so far.
I just wanted to point out, at the hackathon, we've done these encodings, right? Like we've done composites, and we haven't encountered interoperability issues in terms of the keys. And in the drafts today, we support like different encodings. So that hasn't been an issue. So I guess what we're talking about here is if we lock it down further, or this is what I'm thinking, is this going to cause interoperability issues?
Dennis Jackson.
And
Sorry.
Can I just jump, Dennis? Also to the hackathon point, so we have this table in the draft that lists the approximate sizes of all the objects in the test vectors.
Mm-hmm.
It is approximate because, as I pointed out at PCOP yesterday, dare encoding an integer is not a fixed length operation. So we're not going to get these down to fixed length regardless of what we do. Dennis.
Dennis Jackson, Mozilla. Yeah, I think a single fixed thing is by far saves everybody a lot of time and energy. So yes to that. Richard Barnes in chat has got a proposal for what that single format looks like for each thing. I think that looks pretty good. I think just keep it simple.
Okay.
The chat's probably going to be a mess. Can we make sure that's in the minutes, or Richard, can you send that to me privately? Or on the
Yeah,
list or
I mean, I
something?
can just recap it here at the mic. X25519, X448 already have fixed length byte string things. For the P curves, use the uncompressed format, as some other folks have said. And for RSA, encode an integer as a fixed length big Indian thing. Even if technically you're not going to use all the bytes, like an RSA 2048 key has a fixed maximum length, so just make that the fixed length.
Yeah, so you're getting into black box.
The mistake here would be
problems
considering
there.
RSA as the algorithm as opposed to RSA to fixed size.
Right. So if we're going to pick one encoding amongst the many options that are standardized in RFCs, we can go in the RFCs and pick them. We can as Richard says, we can fish around in RFCs and pick the best one that's standardized. The question here is, should we do that? Or to Victor's point, anything that's allowed today needs to be allowed in the future because we have a design requirement that we're not allowed to break the black boxness of the traditional thing.
So
that's the question here.
The point I enqueued to make was that the point, so to speak, at which this really matters is when we look at what we're going to hash internally to the composite count, right? And dear God, let us not have multiple versions of that. Like, let's have a single calculation for when you do P256 plus ML count, right? Let us not have that vary depending on how you sent that point over. So,
right. So I'm hearing that I definitely need to tighten up the combiner section to be clear that if you take a key in some other format, you must convert it to format blah before hashing it. Certainly that's tightening up I can do.
Yeah, so like we're gonna have a preferred format anyway. And so I don't see why, and if we talk about like what you send on the wire, since this is public data, it doesn't, like, you're just deciding who's gonna like do some translation. As Tom pointed out, all these things are translatable one to the other. So we have a preferred thing already, just make that the preferred thing. And if you have to do some conversion hassle, like, that's on you. It's just a little bit of extra code to convert.
Yeah.
Sorry, Scott. Richard, before you walk away, does your argument also apply to private keys? Because one of the things on this slide is the RSA private key, D versus Chinese remainder theorem, and there's some computation involved in converting those.
Well, so clearly the hash one thing argument doesn't apply there because we're not hashing private keys. And I haven't thought about the rest of it. So, I mean, I do think that I really strongly disagree with Victor's point about supporting everything in the universe being interoperability, because as I think Scott pointed out earlier, like if you have module A that supports one format and module B that supports a different disjoint set of formats, there's already incompatibility there, and it's not our job to fix that. So yeah, I think I would be inclined to have a single private key format as well, even if there's some cost to doing it. It's not like dramatic. As I said to someone the other day, compared to AI, everything's cheap. So it's not going to be like dramatic costs. So yeah, I'm not super worried about it.
Thank you, Richard. Okay, we have Scott, we have Victor, and can the chairs start thinking of poll wording for this?
Yeah, I think Richard partially took my what I was going to say, but in terms of public key formats, because of chems, because they use it, obviously you need to fix one. I don't care what. For private keys, that gets a lot more interesting. But again, you have interoperability issues there anyways for existing implementations. So I don't see how you can fix that real well. Okay, thank you.
Victor.
Right. So private keys for RSA obviously are not going to be fixed length no matter how you try. Even if you fix the bit length of the modulus, the private key can be a multi-factor RSA key, or might not have CRT components. RSA private keys are not a fixed length object, no matter how hard you work at it.
Chairs.
Sure.
Can we drive this to consensus?
I'm working on it.
Okie dokie dokie dokie.
Great. Thanks.
I'm breaking it into two questions. First one is, can you live with the document authors picking a single format for the public values?
It is not the same as asking if you cannot leave the author picking.
Yes, this assumes they pick a single, not a highly variable.
Is that choice thing a single foot? Yeah, okay.
It's a single.
That looks pretty convincing.
Okay, this is pretty lopsided as well. I think we're done with that one. The authors will pick a single format.
So yeah, if you have
Just to be clear, the single
comments on
format
that-
is not in ASN1 choice structure.
Yes. If you have comments, you can put it on the list, but I imagine it'll be the most commonly used ones. But if you have comments on what specific format, let us know.
It's not going to be X962, unfortunately, because that's not an RFC.
So the next question is the same question except for private keys.
And so here you mean you're really getting at the MLDSA choice seed expanded both. That's really what this means, right?
I think it would also be the traditional component private key, right?
Also
says
the
private
traditional
key
component.
format.
Yeah, okay.
Yeah.
Somewhat less controversially, but yeah, fair.
But what's the definition of a single format for an RSA key? I don't understand. This is not a well-posed question.
And,
So in the document right now, we say that CRT is forbidden. So like I'm aware that there is one structure that allows either D
I don't
or the
say
broken out
CRT is
five tuple.
forbidden.
It is. It is. We have a sentence in there saying your private key must be D. That's in the document right now.
Before
Yuri, please put yourself in the queue if you want to talk. Deirdre, go ahead.
So
I'm afraid
is
this
this
question needs to be.
No, Yuri, you don't get to jump the line.
Deirdre first.
Thanks,
Go ahead,
Deirdre Connolly. So is this theoretically proposing a single elliptic curve point format for all the elliptic curves that have been standardized elsewhere with their own public key formats or key formats in general? Would that be wrapped up in a single format?
So Deirdre, what I meant in this case was each of the composite algorithms in the document would have a single format.
So each cipher suite, as it were, would have its own format?
Indeed.
That I agree with. Great. Okay. That's very similar to what we're doing in the CFRG hybrid chems. Like we have Peach 56 over here, we have X25519 over here, and they use different elliptic curve point encodings. But they agree, every cipher suite agrees with each other about that single format.
Correct.
Great. Okay, thank you.
Right. So the wording in the document right now is sort of like when the component is RSA, RFC 8017 section 4.2.1 take the first thing. When it's P256, RFC blah 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 section 4.2 take the second thing. Like that's how we've worded it right now.
Okay, great. That sounds a lot better. Thank you.
Henry. Henry. Okay, I'm going to throw you out of the line then. Go ahead, Yuri.
I basically want to amend this poll because the answer for me would be it depends on what single format is picked.
We're leaving that to the document authors is the hope of this question.
Yeah, and we'll put that on the
is the
list too when before we write it up, we'll put it on the list, the ones we're going to use, okay? So
I mean,
that everyone
if you have a strong
can look
opinion,
at.
tell us on the list. That's fair. Or tell us on GitHub.
Clear, as the document stands, it essentially forbids the use of multi-prime RSA because it's pointless in that context, right? Because with just D, you get nothing from multi-prime RSA.
Right.
Yeah, I'm concerned about that myself. I think I'm the other no on this one. I am now.
Okay, I think that was our last slide, wasn't it?
I don't know.
Okay.
Go to the next one.
That one was still a slanted poll, but the no's had good arguments.
Oh yeah, there's of course the last one on the road to working group last call. Go to
Yeah, the
next
last
slide.
slide says working group
The,
last
the
call.
important, the important on the road to working group last call. So just did consensus calls on the encodings. That's great. So we will also figure out the encodings, what we just talked about. If you have comments, put them on the list. We've been doing at the hackathon, we've had independent verifications of test vectors. Of course, we would like more. I think I showed yesterday, so the composite signatures, there's some things, tweaks that need to be done, but we do have at least more than one working together. So that's great. Yeah, thanks to Carl Wells, Dan Van Geest, and others, I can't read his pronouns, who have opened GitHub issues. Actually, a lot of people have opened GitHub issues. I think we've probably fixed about 200 or 400 between the two drafts. So it's been a lot of issues. A lot of you have participated, added pull requests. Just thank you to all of you for your help.
So the specific point here is the reference implementation is new since Bangkok. We've already ironed a bunch of bugs out. I don't want to push this thing to RFC if there's still bugs in the test vectors. So I would like
so we're trying to get
at least 2 or 3
verification.
independent verifications of every single test vector before we push this thing through.
Yeah, so that's where we are. We did have some bonus slides. I'm not sure if you have.
Oh,
we
no.
probably don't have time for those, so yeah, I know you want to get on to the next part. So I was just going to show some of the hackathon stuff, but I talked about that yesterday, so we don't have to do that. So I think that's it. Thanks. Thanks, Mike, too. Hopefully you're more awake today.
Yeah.
Okay, thank you for keeping it respectful. That was, I know, a long journey, but we got there, I think. As a means of confirming all of this on the list, we're going to do a call for adoption when the next version is posted. There was a couple cleanups that the authors wanted to do. We'll let them do them, and then we'll do a call for adoption and find out whether everyone on the mail list agrees with the polls we just did here in the meeting. No, a call for adoption. It is not a working group document yet. Okay. Next presentation.
I'm sorry, Russ, what's not a working group document?
I'm sorry. I'm working group last call. Sorry. I'm sorry. No,
It took us 5 years to get adopted.
You're correct.
Don't make us do it again,
I used the
please.
wrong term. Fair.
Consensus call makes sense before working group last call, right?
We're going to try working group last call.
Now I am, okay.
So given the small amount of time, which of the presentations at the last bullet of the agenda do you want to start with? The presenter. Hello? Where's the presenter? I got a slew of slides this morning. Which ones do you want to start with? Come. Can't hear you. Since you have so little time.
It's okay. So we will first present
He's the one for sharing slides. Show him which ones you want.
Which document?
That's what.
Thank you.
Sorry, since we only have 5 or 8 minutes, so I will present the most simple one, and we have another 2 draft. So this one is for the certificate status information mechanism description updates to OFC 5280. Next slide. Okay, so the motivation here is that when we use RFC 5280, we always find that there have been many years ago. So nowadays, we do the analysis and we want to make the collection of all the difference with nowadays technologies. So in details, OCSP including general name elements was updated in 2013. The related updates to RFC 5208 described in this draft provide alignment with the 2013 specification for the S.509 Internet Publication Key Infrastructure Online. Certificate status protocol. Next slide. So in our draft here is we do the new basic process verification process. Oh no, it's not the light. We just outline the new things we update for the old updates. The first one is that we update in the overview of approach is in the section 3 and update in the operational protocols, and update also in the authority information access, and the CRL and the CRL extension profile. And next is basic certificate processing and internationalized names in distinguished names, international dominance in general name, and also the international electronic mail addresses. And the last one is the informative reference. Next slide. So the security condition and conclusion is that OCSP including general name elements was updated in a long time ago. So the related updates to the old updates description in this draft can help us to under the apps more easy. So next. This is the second. Okay, only 2 minutes. So it's the technical guidelines for the digital certification verification of web server for internet browser. Next slide. The motivations here is that in IETF 509 has no related guidelines, and also RFC 5280, and we do some we propose a new pace validation here. Next slide. Next slide. Yeah, this is the most important thing is that's the new basic pass verification process. The first one is we start and do the initialization, and then the basic certification Then we will secretly do the verification of the the trusted chain here. If one is passed, then we'll go back to the process. Finally, if we have judged that is the last one chain nodes, then it will warm up and stop. And during this process, it will be do the introduction with CRL server, OCSP server, and also the CT server, and also web servers. Next slide. So based on the best practice of the internet servers browsers, we will outline the complete and the necessary web PKI certificate security verification process here. In Word, we have supplemented lots of the verification process, and we have supplemented the verification process of OCSP and the CT mechanisms. Next slide. So in the section OCSP validation and the CTF validation, we have provided additional descriptions of the working process of the latest OCSP and the CT mechanisms. Next slide. Next slide. Okay, I think the time is...
The time is up, Sean. You're the only one in the queue, and we're going to close it.
Hey, thanks. This is Sean Turner. I did a quick skim of the first draft that you talked about, and I was trying to, there's old and new text, and I was just trying to okay, well, what changed? And it took me a while. You're just updating the references, right? Just updating to the numbers for many of them. I don't know that you need to do that at all. The update mechanisms the IETF has already set in place when the document does an update. While it's not as clean as it could be for the average user, the idea is that you can figure out which documents updated what. And I think for the vast majority of that's okay. So I'm not sure that you need that one. And for the validation one, I thought David Benjamin did a draft not too long ago about path validation, and it also said it updated it. So I don't know that that one's needed either. So I just want to say that. Thanks.
Thanks.
Okay, thank you. We'll continue this discussion on the list.